The second reaction that we are going to explain it today is the reaction between acid and metal. This reaction produces two products. The first product is observed through the formation of bubbles as represented in the given figure, which is hydrogen gas. This hydrogen gas is identified by the release of pop sound with a burning match. And the second product is a salt. This salt is a compound formed from the cation of the given metal and the anion from the given acid. Let's take this example, the reaction between magnesium metal Mg and hydrochloric acid HCl. It's a reaction between acid and metal. So the first product is hydrogen gas H2. The second product is a salt. The way to determine the formula of this salt is formed between the cation of the given metal. This metal is Mg, its cation is Mg2+, and the released anion from the acid Cl-. So Mg2+ and Cl-, according to the crisscross method, you will get MgCl2. You can write the net ionic equation. Here HCl, it dissociates, it's in the form of H plus and Cl minus. MgCl2, it's Mg2 plus 2Cl minus. Cl minus is the spectator ion, the ion that does not interfere in this reaction. So the net ionic equation is Mg, which is solid, it's a metal. It reacts with 2H plus, don't forget that it's a balanced equation with two hydrogen ions, to produce Mg2 plus and hydrogen gas H2. The third reaction is the reaction between an acid and carbonate. This reaction produces three products. The first product is carbon dioxide gas CO2. Look at the given figure. Here we have an acid. Upon the addition of calcium carbonate, it produces this effervescence, which indicates the release of gas. The released gas in this case is carbon dioxide gas. The second product is water, H2O. So here the first two products are carbon dioxide and water, and the final product is salt. Let's take the following example. The reaction between nitric acid, HNO3, and calcium carbonate, CaCO3, which is a solid. It's a powder as represented in the given figure. Don't forget that the first product is carbon dioxide gas, CO2. The second is water, H2O. The third is a salt. This salt is formed from the cation of the carbonate, Ca2+, and the anion from the acid NO3-. So its formula is CaNO3-2. To write the net ionic equation, HNO3, you can write it as H plus NO3- since it's an aqueous solution. CaCO3, it's a solid, so keep it CaCO3. Here CaNO3-2, it's an aqueous solution. It dissociates, it produces Ca2+ and 2NO3-. Here H2O, keep it H2O, and the same for CO2. The spectator ion is the nitrate ion, NO3-. You can cross it from the equation. So the final equation is 2H plus CaCO3. It gives Ca2 plus H2O plus CO2. Don't forget that the equation must be a balanced equation, and you should mention the physical states. The last reaction that we are going to explain it today is about the reaction between acid and a base. An acid that releases hydrogen ion H+, and a base that releases the hydroxide ion OH-. This reaction produces two products. The first product is water molecule, H2O, and the second product is the salt. The salt is formed from the cation of the base and the anion of the acid. For example, the reaction between hydrochloric acid and sodium hydroxide, which is a base, NaOH. The first product is H2O. The second product is a salt made up from the cation of the base, Na+, and the anion from the acid Cl-, which produces NaCl, sodium chloride. To write the net ionic equation, HCl, it's H plus and Cl minus, NaOH, Na plus and OH minus, H2O, keep it H2O, NaCl, it gives Na plus Cl minus. So after crossing Na plus and Cl minus, you will get H plus OH minus. It gives H2O, which is the general form for the equation for the reaction between acid and base. The acid, which is represented by H plus, the base, which is represented by OH minus, and which produces H2O. This reaction, the reaction between acid and base, is called a neutralization reaction, and it's classified as an exothermic reaction since it releases heat. We observe an increase in the temperature during this reaction. Also, during the reaction between acid and base, the concentration of H plus and OH minus ions decreases with time, and we will observe the change in the pH value of the solution. At the end of the reaction, there is three possible cases for the nature of the solution, whether it's a neutral, acidic, or basic, according to the initial mixture. If the initial mixture of reactants is a stoichiometric, what do I mean by stoichiometric? That both reactants, here the acid and the base, reacted completely. So at the end of the reaction, the solution is said to be neutral since acid and base reacted completely. While if it's not stoichiometric and the acid is in excess, the ratio of the acid is greater than the ratio of the base, then the solution is said to be acidic, due to the remained amount from the acid at the end of the reaction. While if the base is in excess, then the solution is said to be basic due to the remained amount from the basic solution at the end of the reaction. Thanks for listening.